Example 9. A married couple has $15,000 towards the purchase of a house. For the house that the couple wants to buy, a down payment of $20,000 is required. How long will the money have to be invested at 7% compounded quarterly to grow to $20,000? All right. In example 5, this was part J. So this is the same thing as example 5J. And when we read through this problem in example 5, we said this was a compound interest problem, okay? So this will be the formula that we will be working with. Let's revisit quickly why this is a compound interest problem, okay? First of all, you see the phrase compounded quarterly. That eliminates simple interest. But what's going on here is you've got this married couple. They are saving up for a down payment on a house, and they have $15,000 that they are going to invest. So they are investing that one lump sum, and they're going to have it grow to be the $20,000. And that is why this is compound interest, because they are investing or saving they're saving one lump sum. They're not making regular deposits here. Okay, so saving money and doing so through a one-time deposit. Okay, all right, so let's go ahead and figure out what we're solving for and give the value for all the other variables. Okay, so if we read the question, it says, how long will the money have to be invested? Okay, how long? So this is going to be another problem where we're solving for time. Okay, so just want to give you as many examples of solving for time as I can. Okay, so let's see, what else do we know? We know that the interest rate here is 7%, so that's going to be 0.07. The interest is going to be compounded quarterly, so that means 4 times a year, so M is 4. Let's see here. A and P, we still have to figure out. So P is going to be how much money, it's the one lump sum that's deposited or invested. So the P value here is 15,000. And then we want to have, however long, we want to have $20,000 down the road. So we're going to want to have an account balance of $20,000. Okay, so there's your A and your P. All right, we're going to go ahead and plug all this in, and then we'll start solving it for time. Okay. All right, so let's plug this in. We're going to get 20,000 is equal to 15,000 times 1 plus 0.07 divided by 4 raised to the 4t power. Okay. All right, so let's start solving. Okay, again, you have an exponential equation. You're solving for time. Time is trapped in the power or the exponent. Okay, so we're going to follow the same steps that we followed in example 8. Okay, first thing you're going to want to do is isolate the thing that contains the t, okay, which is this. Okay, this quantity, 1 plus 0.07 divided by 4, is in parentheses, and it's raised to the 4t power. So all of that is tied together. You can't break it apart. Whatever is in this box is multiplied by 15,000. Okay, that 15,000 is not inside the parentheses. It's not raised to the 4t power, so it's separate. Okay, so you want to isolate the thing in the pink box. So you're going to start, since you're multiplying by 15,000, you're going to isolate it by dividing by 15,000. Whatever you do to one side, you have to do to the other. Okay, so we're going to start that way. Okay, so I'm going to go ahead and get my calculator here. Okay, and I'm going to type in, what is 20,000 divided by 15,000? Okay, and we're going to get this number. Okay, so this is a decimal. Okay, it does repeat. Okay, but again, there is no rounding here. You're going to have to carry all the digits. So here is another neat little trick you can do. Okay, because this decimal repeats, anytime you have a repeating decimal, you can actually turn it into a fraction that's reduced. So if you go to your math button, okay, option 1 is going to be to convert this decimal to a fraction. So hit option 1 and hit enter. and it's going to take the previous answer and convert it to a reduced fraction. So the 1.3 repeating is actually the same thing as 4/3. Okay, so 20,000 divided by 15,000 reduces to 4/3. Okay, so you can do that. Okay, the 15,000s will cancel, okay, on that side, and so that's going to leave us with 1 plus 0.07 divided by 4 raised to the 4t power. Okay, so that's our first step. We got the quantity that contains the t isolated. Okay, so once you've got it isolated, your next step is to take the logarithm. You're taking the logarithm so that you can bring the t out of the power. Okay, so we're going to go ahead and, like I said, use natural log here for everything in this class. Okay, we're going to take the logarithm of this side, so whatever you do to one side, you have to do to the other. Remember, logarithm goes on the left side, not the right. Okay, this is going to be some messy decimal, so we're going to leave it as the natural log of 4/3. Okay, and then the reason we did this is now on the right side, we have the logarithm of something to a power. Okay, so you're going to take that something in the next step, and you're going to be able to bring it down in front. Okay, and again, I brought this up in example 8. You absolutely do not have to, figure out what this is inside the parentheses. If you want to, you can. If you do, you will have to carry all the digits. Okay, so that's why I don't particularly do it. I just calculate it at the end. But if you want to, go ahead and do that, but just keep all the digits. Okay, so in the next step, we're going to have natural log of 4/3, okay, is equal to 4t times the natural log of 1 plus 0.07 divided by 4, okay? And you don't rewrite the exponent because it has moved down in front, okay? All right, so now this is going to be some messy number, okay, some messy decimal. Again, this side is no longer 4/3. It's the natural log of 4/3, which turns it into a nasty decimal. This quantity, the natural log of 1 plus 0.07 divided by 4, also an ugly decimal, okay? So we are going to solve at this time, not for t, but for 4t. Remember, when you're solving for time or you're looking for the time value, you always solve for m times t, okay? So we want to isolate this thing in the box, okay? Since we're multiplying it by this crazy decimal, okay, we're going to divide off the crazy decimal. Okay, so we're going to divide both sides by this logarithm to get this 4t by itself. So we'll do that in the next step. Okay, so this is going to become 4t is equal to the natural log of 4/3 divided by the natural log of 1 plus 0.07 divided by 4. Okay, so now we're going to divide the two logarithms, okay, and then that will give us a decimal for 4t, and then we'll go from there. All right, so let's go back to our calculator. Okay, so let's see here. Let me clear this. So make sure it's two separate logarithms that you're entering in. Okay, so this is going to be the logarithm of 4/3, close parentheses, divided by the natural log of 1 plus 0.07 divided by 4. Okay, close the parentheses. Okay, so hit enter. You're going to get this decimal. So I'm going to go ahead and write it out, 16.5824007. Okay, so we have solved for 4t. Okay, and then remember, anytime you're solving for time with these complicated formulas, you need to round the decimal up to the next whole number. Okay, so this side will round up to 17. 4t will stay on the left. And then once you've rounded up the time, just to ensure you have that this couple has enough time for the payment to grow to $20,000, you don't want to be short even a little bit. You round up, and now you can interpret your answer. The 4 in front of the t means that we're interpreting the 17 as the number of quarters. Okay, so it is going to take this married couple 17 quarters to turn their $15,000 into $20,000, investing at 7% compounded quarterly, okay? So remember what I explained in example 8, okay? If, when you read the question, they don't really express how the answer should be stated. It just says how long is it going to take. So in particular on MyMathLab or on a quiz or a test, I might ask you, how many quarters is this going to take? And then the answer would be 17. But you could also be asked to give the answer as years and leftover quarters, okay? So if we did that, I will do that at the bottom of the page. I will convert 17 quarters into years and leftover quarters. So what you're going to do is we're dealing with 17 quarters. That's how long it's going to take the $15,000 to grow to be 20,000. So we're going to take 17, we're going to divide by 4 because that's the number of quarters in 1 year, okay? And if you go ahead and do that on your calculator, you get 4.25, okay? So what this whole number means, okay, is 4 whole years, and then 0.25 is what's left over, okay? So this is going to be 4 whole years, and then you might have to convert the 0.25, to quarters or whatnot. Just kind of using common sense here. 0.25 is like the value of a quarter, 1 quarter. So this is going to be 4 years and 1 quarter. Okay, 25 cents, 1 quarter. But again, you may not get such a nice answer like this. So let's just walk through, the details of how you can interpret this as 1 quarter. So remember what you do. Okay, so I divided this out, 17 divided by 4, and I got 4.25. That means 4 whole years. Okay, so then you calculate the number of quarters in 4 years. So I have 4 whole years, and there's 4 quarters in a year. So 4 years is 16 quarters. Okay, I'm dealing with a total of 17 quarters, and then I subtract out. There's 17 quarters. It's going to take the couple to get to $20,000. I'm subtracting out 4 years, which is 16 quarters. That's going to leave me with 1 quarter left. Okay, so this is another way you can express your answer. 4 years, 1 quarter. Okay, you could even go a step further. As far as thinking about this, 1 quarter is 3 months. So you could also say 4 years, 3 months. If you had left the answer like this, 4.25, it would be 4.25 years. Okay, so you got to be careful with how the question is stated. I know in examples 8 and 9, it wasn't specific. It didn't ask you to state the answer a certain way. But MyMathLab and quizzes and tests, they will ask you a certain way to state the answer. So make sure you understand how to convert between all the different ways you can state the time values.